Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be looking at simulating buoyancy. As you can see, we've got a flat plane and we've got a boat, and the plane is being moved by a noise shader and the boat is reacting accordingly. In order to achieve this, we're going to be using a combination of a little bit of MoGraph and also quite a bit of Expresso, including the matrix to HPB node, which is something I've never used in a tutorial before. But anyway, without further ado, let's see if we can make this happen. We'll begin by grabbing a plane object, so we'll get one of those. We'll leave the width and height at 400 and change our segments in the width and height to 20 and leave it at +y. That's absolutely fine. The next thing we can do is think about how we're going to deform this. Now, if we come up to our MoGraph menu here and grab a hold of a shader effector, that's going to be a good starting point for this. Now in the shading, we can place a noise shader in there. And what I'm going to do, I'm just going to open my noise here. Now most of this I'm going to leave as it is. The only thing I'm going to change is the low clip and the high clip. I'm going to put 20% in there and 80 in there. This is so that it just gives us a few more darker areas and a few more brighter areas, which should help to create the sort of wave effect. And what we can then do is drop this into our plane and in the deformer tab, switch on the deformer and use polygon as the actual mode for the deformation. Straight away you can see that there is a change, but we need to come into our parameters and we need to decide what we're going to do in order to make this work. Well, we don't need scale. We do need position though, and we'll say let's just give it a go in the Y and see if we can get any results there. We'll say 5. Well, we do get something, but we didn't get it along the Y axis. We got it along the Z axis. So let's try the X axis and say put 5 in there. Also, I'm going to change my display to garage shading lines so that we can see a little bit better what we're doing. Let's just try doing this. Now we can see that we're getting something. So we're getting something along the X axis there, which we don't want. That's not what we want at all. It looks as if we should get it along the Y, but we don't. We actually get it along the Z if we use the Y. So let's try using it along the Z axis, and it does actually then work. Now the reason for that is because of course we're deforming along the normal, and the normals always point in the Z direction. So if we go into our options, I'm going to turn on display normals. If I can find display normals, I'll turn it on. Should be able to see show normals. Yeah, polygon normals, that's what I'm looking for. Okay, great. So they're now turned on, but at the moment, of course, they're not visible because the plane is still a parametric object. It's not a geometric object yet. So we've got a bit of an issue because, of course, in order to make our boat move around on the surface of our sea, we're going to have to use these polygon normals, and we're going to have to pass them to the position and rotation of the boat. So that presents us with a little bit of a problem here. So how are we going to get round this? Well, for a start, if we just make our plane, I'll just take the shader out for a second. If we make the plane editable and we drop the plane back in, we now get the same result. But the thing is, if I go into polygon mode here and I select my plane, all we're getting is a flat plane. So we're not actually getting any kind of usable data from this plane at the moment because it's still actually a flat plane. It's only when we click out of there that the shader effector then starts to deform the polygon, but it's not really deforming deform the plane, I should say, but it's not really deforming the plane at all. It's an illusion. It's like a mathematical sleight of hand trick that's being played here, because the shader is effectively creating an instance of the plane and then deforming the instance as opposed to the plane itself. So that's not what we want, because it's just no good to us whatsoever. So how are we going to get around this? Well, the answer to that is to use a MoGraph matrix, and that's what we're going to do next. Once again, we'll come up to our MoGraph objects here and get a hold of a matrix. Straight away we're getting a count of 40 by 40 here, which is too many. We just want 21 by 21, because we actually have, if we go into our plane and we go into our structure manager, we can see we're in points mode. So we can check the number of points, and we can see that we've got actually 441, because of course we're going from 0 to 440. So we've got 441 points. Therefore, in our matrix, we've got 21 by 21, giving us 441 matrices. Our size we need to increase. So basically, we need to make this match up with the points of our plane. So let's just increase that, make it 20 by 20. And now we've got a matrix literally lined up with every point on our plane. And that's great. That's exactly what we want. We're going to make the matrix invisible shortly, but what we'll do first is assign the shader effector to the matrix. So let's just do that. If we go into our effectors, we'll just grab a hold of our shader and drop it in there. Straight away we can see that things are happening. And are they happening in the right plane? No, they're not. So we've got to do a bit of an adjustment. So in our transform here, what we need to do is just have a look and see where we are. Let's try 10 in there. And now we're getting something slightly different, but it's still not correct. So the problem may actually be that our shader effector is not quite orientated correctly, or rather possibly our matrix isn't quite orientated correctly. But let's try our shader effector. If we rotate that by 90 degrees, come into model mode before we do that, just rotate it by 90 degrees. No, it doesn't make any difference. So it doesn't matter what you do with the shader effector. You've got to work within the matrix. So we need to work here and say 90 degrees. And now we're starting to get the result that we desire. We're getting it in the correct plane. So that's fine. That's all working really well. So we're well on the way to getting our matrix to deform our plane. In order to make that happen, we need to start working with Expresso, and that's the next step. I'll grab a null, call it Expresso. In my tags, come down to programming tags and give it an Expresso tag, and we're ready to start having a go at this. I'll bring in my plane and give it an object port, and my matrix I'll also bring that in, and I'll give that an object port. Moving on from here, I will need a data node, so I'll come down to motion graphics, data. Place my object into the object port there, and in the index here, the first thing to do in actual fact is get an iteration. So we'll come down to iterator, put an iteration node in there. I'll just put it between the plane and the matrix nodes there, and plumb my iteration into the index. And then within the iteration node, it will start at 0 and it will end at 440, because we want to work with all of our matrices and pass those to the points of our plane. And in order to do that, we need a point node. So we'll come down to points in the general menu here, plumb my plane into the object port, and in the point index I will need to plumb my iteration into there so that the indexes with the data node and the point node are both synchronized, and then I'll need to add a point position. I also need to add a position output port to the data node. And then I can plumb that port into the point position on my plane's point node. And as you can see, our plane is now deformed. So let's just switch off, or at least make the matrix invisible. And there we go. We can see that our matrix is now deforming our plane. At the moment though, there's no animation, and the reason for that is because we've got to go into our shader here, go into the noise, and set the animation speed just to 1. That should be fine. And then if we return to 0, we can see that we're getting some motion in there now. And we're getting something that doesn't quite resemble the sea, but it's working as you would expect it to work. We'll drop our plane object into a subdivision surface, and that will help things along. We'll just rename this C. And now when we play our timeline, we do get something that resembles possibly water, waves on water. It looks more convincing than it did anyway. I mean, it's never going to be real flow, but it's pretty good and it works okay. But anyway, that's the next step complete. So from here, what we need to think about doing is taking the data from our polygon normals from within our plane and passing this data to our boat. If we just zoom in on there so that we can see what we're talking about here, you can see this little black line here. That's the polygon normal. So that normal direction data is going to be useful to us, and we can pass that to the boat. The position is going to be the position actually of the polygon itself. We're going to be using that position to pass to the boat, so not really the polygon normal. The normal direction is used to simply rotate the boat around its various axes so that it rocks and rolls about as if it really is floating on water. That's the idea here, and that's what we're going to be looking at creating next. And by the power of editing, we now have our boat in our scene. The boat itself just started life as a cube. I subdivided it up, tugged a few vertices until I got it into the basic shape. Obviously did some extrusion as well and cut some pieces out for the windows, and then basically threw it into a subdivision surface just to make that. You can make your own boat, see what you can come up with, or a submarine or whatever. It doesn't really matter what it is. Or alternatively, you can just use a cube and you don't even need to use a boat model for this. It'll work fine with anything. But anyway, that's the boat. So what I'm going to do is just drag this down to the bottom of our object list here. And then we can start thinking about doing a bit more work in the Expresso editor. So we'll get the Expresso editor open and do a little bit more work. The first node I'm going to bring in is going to be a polygon node. And at the moment it needs an object, so we'll give it our plane. The index value at the moment is set to 0. We'll leave it at that for the minute. We will be working with it, but not just yet. We also need polygon center and polygon normal. And we'll put the normal in the middle. And this is just for the sake of keeping things tidy. The next thing I'm going to bring in is an adapter again, and this is going to be a vectors to matrix, which is a node that I just don't use very often. In fact, I've not used it in a tutorial before. If you've done any of the Python tutorials, the offset is exactly the same as in Python. So this deals with the position of objects. The other 3 vectors here are all rotational vectors. We're only interested in the first 2. So the polygon normal is going to be plumbed into vector 1 and the polygon center into vector 2. And that will give us the result that we need here. I mean, by all means, have a play around and experiment with some of this stuff and see what happens. But this is the best setup for what we're doing here. Moving on from here, we need a matrix to vector node. Now this is in the calculate menu. So we'll come down to calculate, and it's just here, matrix, or rather matrix to HPB. I beg your pardon, I said matrix to vector. It's actually matrix to HPB. So we need one of those. And we can plumb our matrix into the matrix input there. Now the rotation order is going to be important. We'll switch it from default. We'll use X, Y, and Z. That's the setup that we're going to need here. And then the final stage of this particular step is to bring in a reals to vector So come down to adapters, reals to vector, bring in one of those. And because we've set our rotation order up in the matrix to HPB, H is the X, P is the Y, B is the Z. So we can just simply plumb these in and it will give us the result that we need. And that's the basic setup for making the boat rock and roll around on the sea. So if we drag our boat in, we can give this a rotation port and we can plumb in our reals to vector. And straight away we're getting something strange going on. It's not the way we want it to be, but if we play the animation, we can see that we do actually get the boat rocking and rolling around. But don't worry about the orientation of the boat at the moment. We will sort that out a little bit later. So we'll just return our timeline back to 0. And what I'll do actually is disconnect the boat for now. And I'll set its coordinates back up the way I want them. So let's just set this back to 0, 0, and 0. Okay, so we can see that something is working, but it's not quite what we want. But anyway, we'll move on to our next step, and that will be to create some user data. I'm going to place the user data on the Expresso node, so I'll just select that, just move the window out of the way a little bit. And we can go into user data, add user data. There's going to be 7 user datas added. And what I'm going to do first, I'll add a group and I'm going to rename this controls and just drag it away from there. And then my first data I can drop into the controls. The first thing we're going to set up will be sea roughness. It will be a float data type. We'll use a float slider for the interface and a real value. It will have a step of 0.01. So this is a tiny step value we're using for this. And our minimum value will be minus 0.9 and our maximum value 0.3. And we'll clamp those values. The default will leave at 0. So that's our sea roughness, and we can add some more data. This will be rotation polygon. So I'm going to allow us to use any polygon that we choose to from the plane to be the polygon that influences the rotation of the boat. Just gives it a little bit more versatility. Again, the data type will be float, the interface, a float slider, and once again a real value. The step will be 1 because of course really this is not a real value, it's actually an integer, but that doesn't matter, we describe those as real values here. The minimum will be 0, the maximum 440. We'll clamp those values and leave the default at 0. I'm just going to copy this one and call it position polygon. So therefore we can now use a different polygon to influence the position of the boat from that which influences the rotation of it. And again, this gives the setup a little bit more versatility. So that's great, that's done. Our next piece of user data will be called float sync. And as you've probably guessed, I'm going to be using this to give us the ability to actually make the boat sink as well as float. So we'll give that a float slider, somewhat ironically, and change the unit to a real value once again. This will have steps of 1, and once again our minimum will be a value of 0, and we'll have a maximum of 120, and once again we'll clamp the values. And we can start with a default of, let's say 1 for this, just to make it a little bit different. Add some more data. We'll name this one roll. Again, a float data type, a float slider, a real value. Steps of 0.01, so another small value increase here. And the minimum will be -2 and the maximum 2. We'll leave the default at 0 and clamp both values. Again, I'm going to copy this particular data and just rename it pitch. Everything can stay the same, that's absolutely fine. And then I'm going to copy once again and call this yaw. And once again, it's all set up for us and we can leave it as it is. And that completes our user data. So we can hit OK and it's all set up for us. Fabulous. So our next step is going to be to bring in another polygon node. So I'll hold down my command key and just copy this one. I can also then connect my object to the object port there. The next node I need to bring in will be a vector to reals. So I'll just come down to vector to reals in my adapters and get one of those. Now the vector to reals will simply need the polygon center. In fact, I don't even need the polygon normal anymore, so I can take that port away. I'll just delete that port. Great. I also need a math subtract node. This is actually going to be used as part of the setup to make the boat sink as well as float. So we'll come down to calculate, get a math node, just bring that in here, just place it up there, and we'll change the function to subtract. And we're going to be using the y axis, so we'll plumb that into the top there, into the top input of the math subtract. And then moving on from here, I need a reals to vector, so I'll come down to my adapters, select reals to vector, place this over here, plumb the output of my math subtract into the y input, and then connect the x and z's. So that's all set up for us. This input is going to be controlled by the user data from the Expresso. So we'll bring that in. And the user data that we need here will be, if we come down to controls, will be float sync. So we can plumb that in there. And we can plumb that in there. And that's all set up ready to use. The last step in this particular stage is to bring in a memory node, because I want to add a little bit of inertia to the setup here, just to make the animation just that little bit more authentic. So what I'm going to actually be doing is, as the sea rises and falls, the boat is going to lag behind, as it would in real life. So in the memory node, the first thing we need to do is change the data type from real to vector. Very important we do that. Things will not work properly if we don't. And I've just realized actually this output should be plumbed into the input of the memory node. The history depth should be 10 and a history level of 9. And that should be enough to give us a sufficient time lag behind the sea, which is what we want. It should give us enough inertia. Great, so that's that part of the setup complete. Moving on from here, we can add some more user data to the Expresso node. Come down to controls and we'll add the position polygon, and we'll also add the rotation polygon. Just bring that a little bigger. So our position polygon can be plugged into the polygon index of our top node here, because of course this setup is controlling the position of the boat. And our rotation polygon can be plumbed into our bottom node and control the rotation polygon. So that's great, that's set up. I'll just move this boat out of the way, this boat node. Fantastic, so that's another little bit of our setup complete. I'm going to give my boat a position port at the input, make this a little bigger and bring the position port up to the top. Let's just plumb in the memory node. Just straight away the boat has dropped, and at the moment you can see that it's actually below the level of the sea, which is not where we want it to be. The reason for that is because in this polygon node, in fact I'll select both the polygon nodes because it applies to them both, I didn't check use deform port points, and that's very important. So if I check that, that will make a difference. It won't initially because we're going through the memory node. Now all we need to do, if I just grab a hold of Expresso, we can then select our position polygon, and we'll probably choose 209, which is about the middle of the plane. So I'm just going to select that there. If I just do this a few times, you can see that the memory node is having an effect, and it does play catch up because we've got that time lag. So let's just go to 209. We are actually in the correct place, but again, because the memory node is playing its part, we're not quite there yet, but we've only got to move our rotation polygon there, which isn't even connected at the moment, but because we're making an action, it has moved it. And now the boat is sitting on the water exactly as we'd like it to be. And if we plumb in our rotation as well, we've still got the issue with the orientation of the boat being wrong, but we still will get the boat moving around, and it will be actually moving up and down as we need it to, and there will be that lag. So we're on the way to getting it to where we need it to be, but we're not quite there yet. So let's just unplumb these two, because we will be putting some more nodes in. Grab a hold of my boat once again and zero everything out. I'm just going to make the window even bigger. Just bring that to its pretty much its maximum size there. And I'll move everything to the left a little bit more, and then move the boat over to the right so that we can fit the nodes in that we need to place in here. First thing I need is another adapter, and again I need a vector to reals, and this will be plugged into our reals to vector. I then need 3 multiply nodes, so I'll come down to calculate, math, and start doing some work with these. I'll just change the function to multiply, command drag to copy out a couple more of those. And we can plug our X into the top, our Y into the middle one, and our Z into the bottom one of those. And then the final step here is to get another reals to vector and connect the outputs accordingly. Now this part of the setup is going to be used to actually add roll and also pitch and yaw to the boat. So we're going to be using our user data to do that. I'll just get a hold of the Expresso and bring it closer to us so that we can work with this more easily. And then we can think about adding the controls for roll, pitch and yaw. Just make it a little bigger. The yaw will be plumbed into the top math multiply, the roll into the middle one, and the pitch into the bottom one. We can then move our Expresso back to its original position. And then while we're here, we might as well add our final control, which of course is C roughness, and I'm just going to move that to the top. The float sync can be left where it is. I mean, you can reorder these as you like, but I'm not going to mess about with that because it can be a bit fiddly. But the C roughness I will put at the top for the simple reason that I'm going to then select my shader and drag in from the shading the noise. Drag that into here, come down to shader properties and select contrast, and then plumb the C roughness into there, because that's how we're going to be controlling the roughness of our C. It's the contrast that we need to adjust in order to do that. Okay, that's great. And that completes the nodes for the Expresso setup, and then it's going to be just a case of plumbing in the position and the rotation. That's all we need to do in order to finalize this. So without further ado, let's get this set up. We'll plumb in the reals to vector into our rotation, and we'll plumb in the memory node into our position. And now if we run the timeline, let's just see what's happening. So our boat's sitting in the water and it's moving up and down with the sea. At the moment, it's not rocking and rolling for the simple reason that we've got nothing in the roll. So if we just set that to 0.2, I'm just going to set that to 0.2 just to give it a little bit of roll. And now you can see that it is starting to move around in the way that you would expect it to. And it's subtle. The reason I've done that is because if we go too mad, it will be, well, we can make it ridiculous. I mean, we can do this kind of thing, but that's perhaps a bit too much. But, you know, it gives you the option to be able to do it. If we just stop the timeline and we'll bring this back to a sensible level, just make it 0.2 once again. The pitch can be used to set up the classic Titanic sort of shot, and if you then use the float sync as well and bring that down, we can set that up there. The yaw, again, this is just the direction that the boat faces in, so we can set that up however we like. If we bring that to about there, we'll just run the timeline again and see what we're getting. A bit too much drama there. I think we need to just calm that down. So the thing to do then is to set the sea roughness. If we bring this down to a sort of very low level so that we get the sort of calm after the storm, that might work perhaps a little bit better. And then again, we can alter the pitch just to bring this over here. And there you have it. I mean, of course, if you wish to, you can completely sink the boat so that it's below sea level. We can just literally bring it down to there, to 120, and it will be beneath the sea when we run the sea, or run the timeline, I should say. Just bring that back up a little bit. So you can see that this is a highly versatile setup, and it does allow you to do quite a bit with it. I mean, again, the rotation polygon, we can just alter that and set it up so that there's a subtle difference in what's going on. I mean, these two, as I said, I just put these in to give it a little bit of versatility. Most of the time, I think you're going to keep it at position 209 because it is about the middle, but you can place it anywhere in on the sea. It's entirely up to you. But as I say, I think mostly you're going to leave it at 209 because it will be in the middle. But it's just to give you that extra bit of versatility. But anyway, that gives you an idea of what we can do. I mean, with the pitch, if you want to, you can totally turn the boat completely upside down, alter the float sync so that it's a little bit higher in the scene, and run the timeline. And there you go. You've got your boat completely upside down. It's again, take your sea roughness down to 0.9, and it still moves a little bit, but it just gives you that opportunity to turn the boat completely upside down. But anyway, that sort of gives you an idea of what we can do with this. We'll just change our pitch and just bring the boat back to 0 and run our timeline. And now we can see that it's just such a subtle amount of movement in the boat that there's perhaps not quite enough, so we can bring that back up and set it moving around again. And that's great. So you can see that it's about creating this synergic balance between the different controls here. And of course, they're all fully animatable, so you could set a situation up where perhaps you've got a calm sort of sea and the boat's just moving subtly, and then gradually increase the roughness until you end up with, well, a much rougher sea. You could then bring some pitch and roll in there and change the yaw maybe subtly, and then gradually create a situation where the boat is going to sink. But yeah, it's all possible. There's so many different scenarios that you can create with this. But anyway, I'll leave that to you. You can have a go at that and see what you can come up with. But anyway, for now, that just about wraps this one up. It completes the tutorial. We've achieved what we set out to achieve, and you can see that it all works exactly as we wanted it to work. I mean, that business with the boat being all over the place initially, we've solved that when we added this part of the expression. That took away that problem because, of course, the pitch, roll, and indeed yaw were set to 0 initially, so we were multiplying by 0. So it's this piece of the Expresso expression that's prevented that from happening. But anyway, that just about wraps this one up, as I say, and I'll leave it to you to have a play around with. So I hope you've enjoyed this tutorial, and if you have, as always, please give the video a thumbs up, and if you haven't subscribed to the channel yet, then please do so. And of course, wherever you happen to be on social media, please share the video, because all of this good stuff helps to keep the channel moving in the right direction. For now, that completes this one, so I'll see you very soon on the next tutorial.